Alright guys, so we are going to do a circles review. This is basically our week 1 of our virtual distance learning. We did this during our live class, so if you think that you already, well first if you attended the live class, you can probably just skip ahead in this video. But if you want to just get a recap of what we did, just follow along. So you do not have to use these notes exactly. Like I already sent it out to you, but you do not have to print it out. You can just get a blank sheet of paper and your pencil and Desmos if you'd like, or a calculator, but you do not have to print this out. If you want to, that may make it a lot easier for you, but that is completely up to you. All right, so let's go through our notes. So for parts of a circle, our vocabulary is very, very important for this unit. Number 1 is line AB. Line AB is a secant. It goes right through the circle in 2 places. Number 2, line CD. CD is a tangent. That is letter H. OG is a radius right here from the center to one part of the circle. HG is a diameter. It goes to the center and it touches both sides of the circle. So that is letter C, diameter. And on your paper, you don't have to write out all these words. If you want to just write number 1, A or I, number 2, H, 3, F, that's perfectly fine, as long as I can see that you're following along. Number 5, angle ACB. Because our vertex is on the circle, that is an inscribed angle, letter D. Number 6, AC, is a chord. It does not go through the center of the circle, but it touches both sides. Letter O is my center. Letter C is my point of tangency. It is a point that is on the circle and also on the line, the tangent line. So that would be point of tangency. And number 9, HOB, angle HOB here is going to be your central angle. All right, so if you understand those vocabulary words, then you're on a good start. All right, let's scroll to the second part. All right, so what we did in class was we typically would fill out this circle and the arcs. Let me make sure it focuses. Hold on a second. All right, there we go. Okay, so we know that our arcs and our central angles are the same. So that means if this arc here is 30, then your central angle of POQ is also 30. Okay? And we know that a full circle is 360, so half of a circle is going to be 180. They already told me that these 2 pieces is 70 and 30, which equals 100. So if I want to find this missing piece, I'm going to do 180 minus 100, which leaves me with just 80. Okay, and so since we have this done, my central angle is 80, my arc here is 80. My central angle is 70, my arc is 70. All right, so you see that we have 2 diameters here. There's a diameter here. And there's a diameter here. An angle that is formed on 2 diameters will be the same. If this part over here is 70, then this part over here is 70. They're on the same diameters. So if I look at half my circle on the diameter, I know half the circle is 180. So if this piece here is 70, if I do 180 minus 70, I am left with 110. And now that I have my central angles, I can go ahead and label my arcs. That's going to be 70 and that is going to be 110. Because your central angles and your arcs are the same. Okay, so now I'm going to zoom out so we can look at our circle. Okay, you do not have to draw your circle on your side. I just want you to recognize it and see how we labeled it. All right, so it says find the indicated measure and classify the arc. So we can find the measure of the arcs because we already filled it out. And to classify the arcs, I have 3 ways to classify. I have a minor arc, a major arc, and a semicircle. Okay, so a semicircle means that it has to equal 180 degrees. A minor arc means it's less than 180 degrees, and a major arc is it is above 180 degrees. So for number 9, it says MN. Well, when we learned about our major and our minor arcs, we also learned that how we name them tells us a lot about the arc. If we name an arc with just 2 letters, it's going to be a minor arc. I already know that. Okay? But I can also know it's a minor arc based on the degrees if it's less than 180. So MN is 70 degrees, and that will be a minor arc. Number 10, NQ. I'm going to start with N, and I'm going to go around to Q. Notice that I'm taking the short way around because I have 2 letters, so that tells me it's going to be a minor arc. If I take the long way around, that's more than half the circle, so that is a major arc. I don't need that. So I'm going from N to Q. So I have 80 plus 30. So arc in Q is equal to 110 degrees, and it is a minor arc. Okay, on number 11, NQR. I start with N, I go to Q, I go to R. Well, this is right on the diameter. NQR, if I add 80 plus 30 plus 70, I'm going to get 180 degrees. The reason why I didn't have to add that up is because I know that it was half of the circle. So it has to be 180 degrees, which means it is a semicircle. Okay. Number 12, MRP. So I'm going from M to R to P. So from M to R is 110 plus R to Q is 70 plus Q to P is 30. Okay, so if I add up all those numbers, I get 210 degrees. It is a major arc. It is more than half the circle, and it is more than 180. So that is a major arc. QR, from Q to R, is just 70 degrees. That is a minor arc. And MR is 110. That is a minor arc. QMR, I'm going to go from Q over to M and over to R. So that means I'm adding 30 plus 80 plus 70 plus 110. Okay, we basically took the whole circle minus this little piece here, right? Went from Q to M to R. So you could also do 360 minus 70, and you'll get 290, whatever way works for you. And that is a major arc. And number 16, PQ, from P to Q is 30 degrees, which is a minor arc. All right, so up until this point, we did this on our online live class. So now we're going to go over the rest of the circles review. So you can do your MathSpace and your eCart. All right, down here. It says find the radius or the diameter of the circle with the given information. All right, so I know that a diameter is from one side of the circle to the other as it's going through the center. A radius is just from the center to the edge of the circle. So your diameter is going to be twice as long as your radius. Okay, so as an example here, if I have a circle and my radius is 5, my diameter is going to be 10. That's how that works. So let's look at the first one. My radius is 38 centimeters. So to find my diameter, I'm going to do 38 plus 38. Okay, and you should get 76. Centimeters. All right, for the second one, your diameter is 24. So be careful here, they switched it up. Your diameter is 24, so we're going to cut that in half to find my radius. So 24 divided by 2 is 12 inches. And then my last one, my radius is 5.8 meters. So if I multiply that by 2, my diameter is going to be 11.6 meters. So depending on what you have, your radius or your diameter, you're either going to divide by 2 or multiply by 2. Just always know that your radius is less than your diameter. All right, so now we're going to do some live examples. This is what you'll see on your math space, and you will see it on eCart. Let me grab my papers here for a second. Just hold on for a second. All right, so we have 6 examples that we're going to go over, 17 through 22. All right, and I'm going to show you the work. All right, so number 17 is an inscribed angle. Okay, in an inscribed angle, your angle here that is inscribed, which is the one that actually touches the circle, is going to be 2 times the amount of your arc. Okay, so here my inscribed angle is 2x plus 4 degrees, and my arc is 96 degrees. So in order to solve this problem, I am going to do 2 times my my angle, so 2x plus 4, and that is going to equal 96. All right, from here you can use Desmos if you'd like, but we can work this out by hand. It should be okay. If I distribute my 2, I have 4x plus 8 is equal to 96. I subtract 8. So I have 4x is equal to 88. Divide both sides by 4, and x is going to equal 22. When you guys are doing this on MathSpace or on eCart, I'm okay if you use Desmos. I will show you Desmos here. Can you see my screen? All right, so here's my app, Desmos. If you don't have it, go ahead and get it. All right, and we can just type in our problem. 2 times 2x plus 4, close parentheses, is equal to 96. You may have to move your graph over a little bit, but there's my answer. X is 22. Okay, so you can use either way. We've used Desmos a lot in class, so it should be fairly simple for you guys at this point. All right, number 18. You guys can't really see this, and honestly, I can't either, so I'm going to make this a little bit bigger. It looks like this number here is 66 degrees, and this number is 100 degrees, and this is an x degrees. Okay, so we're solving for x. What's important here is that they labeled these chords with congruency lines. So I know that those 2 chords are congruent. All right, we learned that in a full circle, there's 360 degrees. So if I do 360 minus 100 minus 66, then I'll get what's left over. So type that in, 360 minus 100 minus 66. So I'm left with 194 is going to be on the rest of these arcs. Oh, let's see here. This arc and this arc will equal 194. Okay, so because I know that these two chords are congruent, that means that these two arcs are also congruent. So we're going to divide by 2. So if you do 194 divided by 2, you get 97. So that means that this piece over here is 97 degrees and this is 97 degrees. So if I were to add up all those 4 numbers, I would get 360 degrees. So my x degrees over here is 97 degrees. All right, let's scroll over to number 19. Another inscribed angle. All right, so I know that my inscribed angle here is 2 times the amount of my arc. So I'm going to do 2 times 18, because that's my angle, is equal to x degrees. All right, so we want to multiply this. What's 2 times 18? And we get 36. So this arc here is 36 degrees. All right, let's go down to number 20. All right, on number 20, I don't know if we did, I think we did this in class. Okay, what we're going to do is basically we're going to be multiplying and making these two chords equal to each other. So that means that this is one chord and this is my other chord. So what we're going to do is we're going to basically multiply each piece of the chord and make it equal to the other piece of the chord. So I have 5 times 6, that's my yellow chord, is equal to x times 10. I put them in parentheses like that because eventually you may have a problem that you have to distribute. In this case, you don't have to. So you can do 5 times 6, which is 30, is equal to x times 10, which is just 10x. And now we can solve as normal. You don't need Desmos for this. We can divide by 10, and x equals 3. 30 divided by 10 is 3. All right, on number 21, this is what we were doing the day before we got out. This was kind of difficult for you guys because we just got out of polygons and it's kind of opposite of what we did. A polygon inside of a circle means that opposite angles are supplementary. So that means that the yellow angles are supplementary and the pink angles are supplementary. All right, at this point, we should know supplementary like the back of our hands. Supplementary are 2 angles that add together to give us 180. So these 2 are pairs. So I'm going to do 4y plus 3 plus 111 is equal to 180 because those 2 opposite angles are supplementary. They are not equal to each other. All right, from here we can combine like terms and solve. So 4y plus 114, because 3 plus 111 is equal to 180. I'm going to subtract 114, and I'm left with 4y is equal to 66. We divide by 4, and we're left with y equals 16.5. It is okay to get a decimal. That's just our answer. All right, that's just part of our answer. All right, we can write that in, 16.5. The other part of our answer, we got to solve for x. So these two angles, 3x plus 135, are supplementary, so they will equal 180. If I solve for x, I'm going to subtract 135. So 3x is equal to 45. To solve for x, I'm going to divide by 3, and x will equal 15. Okay, so I hope that makes sense. We have to remember that when you have a polygon or a quadrilateral inside of a circle, opposite angles are supplementary. All right, and number 22, you guys did very well with this. We did this on like day 1. I have two tangents here that meet at a mutual vertex here, a mutual point. So that means that this tangent is congruent to my other tangent. So therefore, and you probably can't read that too well, but that means that 6x minus 3 is equal to 5x plus 7. And if I want to solve for x, I'm going to subtract 5x. So I have 1x minus 3 is equal to 7. Add 3, so 1x is equal to 10. So x is equal to 10. All right, so that is it for today's notes. So as I said earlier, you guys can, hope you guys can see all that. You can just take notes on your plain white paper. That is perfectly fine. I will post these notes also on Blackboard. I know Blackboard is going in and out with all the heavy traffic on there today, but definitely make sure that you have all this down. Once you've taken all these notes, take a picture, send it to me so you can get credit for your first assignment in the online classroom. And don't forget, you have 3 assignments. You have part of a circle, the Google Doc, you have a math space for circles, and then you have your eCart test. So make sure you do it in that order so you can kind of get help with it, okay? Everything is due by next Monday night. See you guys.